W6BDD, George Blake here again. So, next to the last phase. Actually, this is the last phase of construction, except putting the chassis back together. I got AC plugged in. And, again, I've already checked this out, so I know what's going on. No magic smoke. So there's the tubes. The tubes are on. If you can see sideways, it's 2000 volts plate voltage. The non-engaged, non-transmit current is 0. And I turn the transmit on. My quiescent current is about 50 milliamps, which is where it should be. The plate current, plate voltage is still at 2000. Turn that off. Very carefully go to the back because I don't want to jinx myself here. And we're going to hook this up to ground somehow. There we go. So I wanted the grid voltage somewhere lower than where it was. So this is the new grid voltage. Minus 112, minus 111 is good. The relay operates, according to the data sheet, at least 102. So I've got that. And now we're going to switch on the transmit. There's the transmit, and the voltage is, right, we're about where I want it, minus 104, minus 4. So minus 4 volts on the grid in transmit. And minus 112 in standby. Got that. So, took me a little playing around. Whoops, sorry. Took a little playing around to get there. So I'll go through and explain this a little better. So this is the, having to do with the transmit relay. This guy right there. As you can see, I put some big wires there. That's the 30 kV silicone coated wire that I use for the high voltage. So I carried it through. I put a new relay in. I didn't like the old relay. It didn't work very well. Contacts were too close. And I pulled this one out. This was from a latching relay combination. So two of these together. One latches, the other one flips over. The little lever on top catches it, holds it in position. You hit voltage to the other side of the other coil. That pulls in, it flips it back over. So these were sitting in the drawer at the auction house. And it was the only one that had a threaded bottom. The rest were all just open. No particular way to mount them. So I use this one. This has a little better spacing between the contacts, which I like. And you can definitely hear it go clunk. See it moving in and out there. Much better throw. I took the resistor off, the 2K resistor. So I couldn't find any logical reason for the resistor across there, except that I thought maybe it was for a snubber. Anyone who's not familiar with inductive coils, when you run a current through a coil, it creates a magnetic field. And so depending on what you want the function to do, the magnetic field causes a reluctance. Electromagnetics, coils are lagging, just like motors are. So when you release that current or voltage, that that energy has to go somewhere. The field collapses, and usually a giant spike will come out of a coil. And not wanting to damage the tubes, you put what's called a snubber in. So a snubber basically just shorts the coil out, so all the current goes back into itself until the field goes to zero. Some people used resistors as snubbers. I like to use a diode, so that's the more modern approach on DC coils. So I put this high current diode across the coil, took the resistor out, and so what I did was I used a 2K resistor. Let's turn these off. There we go. So I used the 2K resistor right there and use it as part of the voltage divider. So I got a 2K with 183 volts going through it, and that ties to the resistor below it, which is 5K. The 5K goes to ground, so the divider comes out to around 112 volts. So that's what I run to the grid. The grid runs through the relay, transmit relay, and then the other side of the relay goes to my transmit relay up front, which has approximately 96 ohms. So 96 ohms to ground, and so that pulls down, and that's where I get the -4. So I pulled the -112 down to ground, forms the -4, and then when you release the transmit relay, it goes back up to -112. So that's all redone. So everything's in place. Gas discharge tubes, relay. I did a faux pas when I first turned this thing on, and I didn't have a load. And yeah, the RF decided that it wanted to go through a choke, a bullet type choke, which is up in here, if you can see it, right in there. So that first segment of coils that's wrapped there, yeah, they got a little burnt. So when I go into the auction house, I'm going to take a look, and I know we've got a few of these around, so I'll probably replace that. But for the time being, it's good. Tuned all the coils. Took my tiny SA, and it has a RF generator. Unfortunately, it doesn't have the output for the RF generator is also the input for the low side, the low frequency side. So I couldn't use the tiny SA to also look at the response. So I used a meter, or a oscilloscope. So got the coils peaked up, maximum or the minimum amount of insertion loss. So they're all adjusted. I haven't readjusted. This is the neutralizing capacitor. So anyways, tubes work, high voltage, low voltage, AC. Everything else is done. So next step, put the chassis back together and put it on the bench and see what it does. So that's where we are. I might have mentioned it before, but in case I didn't, I have done a schematic of the entire Collins, the linear, and it's doing the original schematic in CAD, and then doing all the modifications. So I will have that available if anyone would like to obtain it. If you want to, put your email in the comments below, or look me up on QRZ and send me an email. It's Whiskey 6 Bravo Delta Delta, and if you're a ham, you should have access to QRZ, and send me an email and I'll get a copy to you, and then you can see what I did, and if you want to do the same thing, I'll try to guide you through as best I can, and we'll go from there. So there we are, up and running. Everything's clean. Tubes are brand new. Got plate caps, white plate caps in. So, yep. We'll catch you later. W6BDD. I'm clear.